Here, we have a problem asking us to construct a 95% confidence interval estimate for the population mean with the given values. First, it's really important that we know what the symbols are so that we can understand how to solve it. X bar means sample mean. The capital S is the population standard deviation. N equals the sample size. Now moving on to the problem, if the sample mean equals 75 and the population standard deviation is 24 and the sample size equals 36, and assuming that the population is normally distributed, construct a 95% confidence interval estimate for the population mean, and the symbol for the population mean is mu. Next, what are the given values that we know of? From the problem, we know that the sample mean equals 75, the population standard deviation equals 24, and the sample size equals 36. We know that it's normally distributed, and the confidence level is 95%. The equation for the confidence level is this. Our first step is to find the significance level using the z-value table. We're going to take our confidence level equation, and from the problem it tells us that this equals to 95%. Now the significance level equals to 1 minus 95%, which is 0.05, and that gives us a value for one tail. Next, if you want to find out the values for two tails, all you're going to have to do is divide 0.05 by 2, and that will give you 0.025. Those are the values for two tails. Now you're going to take 0.025, and using a z-table, we know that 95% equals to plus minus 1.96. Our next step is to construct a 95% confidence interval estimate for the population mean. Now it's really important, and the first thing that we need is the equation. The confidence interval for the mean equation is this. All we have to do is plug in all the values that we know of into the equation. But if you take a look at the end of this equation, we know that we don't know the standard error of the mean. So the first thing that we're going to do is to figure out what the standard error of the mean is. All we have to do is plug in the values that we know. We know that the standard deviation for the population is 24. You divide that by the square root of 36, and you will get 4. The standard error of the mean equals to 4. Now the middle equation is the z-value. And remember, we already got that value from the last problem that we solved, which is 1.96. Now that we have all the values that we need, all we're going to have to do is just plug in the values into the equation and solve the problem. So what we get is 75 plus minus 7.84. And from here, I'm going to split it up and solve them individually, and I'm going to start off with subtraction. So 75 minus 7.84 equals 67.16. Now 75 plus 7.84 equals 82.84. Now we're going to take those two values and write our equation, which is our answer. So we have 67.16 less than or equal to mu less than or equal to 82.84. 87.84. So our lower and upper limit numbers is 67.16 and 82.84, and it tells us that the population mean falls in between these two numbers. Now, it's really important that we double check our work, and one useful tool that we can use is pH-stat. In pH-stat, choose confidence intervals. Then choose estimate for the mean, sigma known. Do we know what a sigma is? Yes, it's a population standard deviation. So we do know. And the population standard deviation is 24. The sample size is 36. And the sample mean is 75. Click OK. And look how fast pH-stat calculated that very long process by hand that we just did. Now let's double check our work and see if we actually got it right. The z value, if you look at the pH-stat, and from what we calculate is 1.96, and that's correct. And then our lower and upper limit is 67.16 and 82.84. And if you look to the right where pH-stat is, it looks like we got that right. It's really important to know how to do this by hand and then double check your work with pH-stat.